Good day, ladies and gentlemen. We still continue our journey in financial mathematics for mathematics level 4 students, and I've been concentrating a lot on depreciation, and this time we'll still be talking about depreciation, but with some element of appreciation stepping in. So when we talk of appreciation, we are referring to simple interest and compound interest. So this problem says Jacob buys a guitar for 60,000. That's the original cost. The guitar depreciates according to the reducing balance. So it depreciates according to the reducing balance method at a rate of 14% per annum. So that is our story. Then the cost of a new guitar appreciates. So this means they are now taking us to a simple and compound interest at 10% per annum. Now, in 5 years' time, Jacob wants to sell his guitar. They are referring to the old one, and use the money as a deposit to buy a new guitar. We need to determine the amount he will pay. So these are some interesting problems that try to combine both appreciation and depreciation. So it means also here that in your mind you must be picturing the situation where you've got an old guitar and a new guitar. You have to use the old one for some time, you sell it, use the money to deposit to get a new one. So let's start with the old guitar. What is the story of the old guitar? It depreciates on the reducing balance method. So that means immediately I go to my formula sheet as a level 4 student. I look for the formula for reducing balance depreciation. So that is it. So we're told that Jacob buys the guitar for 60,000. The original cost is always your P. Then that guitar depreciate on the reducing balance method at 14%. For how many years? 5 years, because they say in 5 years' time it has to sell and then buy that. It simply means he has used that guitar for 5 years. So we need to see what is the scrap value, or what is remaining value in that old guitar. So I will take 1 minus 0.41, that's 14%, exponent 5, since it's been used for 5 years. Then I multiply this by 60,000. So that will take me to 28,225 rands 62 cents. So this is actually what is left in the old guitar. The old guitar has been used for 5 years. It cost the original cost was 60,000, used for 5 years. Then after 5 years, this is what is left. Now it's time to look at the new guitar. So Jacob wants to buy a new guitar, but the old guitar must be used as a deposit. But there is an interesting story about the new guitar. It says if the cost of the new guitar appreciates 10%, which means what they are trying to tell you is that the guitar that Jacob bought 5 years ago at 60,000 can no longer be bought for at 60,000 now. It has appreciated. And what makes assets to appreciate, or what makes assets prices to go up when there's a simple appreciation? It's like the price goes up. What makes price to go up is inflation. So generally in financial maths, when you read the question and you pick up that there's inflation playing a role, then the formula for inflation corresponds to the formula for compound interest, where in this case we're compounding annually. So that is the appreciation method we use. So what we are telling you here is that the guitar that was 60,000, after 5 years the price must have increased. And what makes prices of assets to increase, or generally goods to increase, is inflation. So that way we'll be settling for the formula for inflation here. And what are we inflating? The 60,000 that was the cost of the guitar 5 years back. So today it cannot still be 60,000. That is normal as long as inflation exists. So let's set the cost of a new guitar appreciates at 10%. So that appreciation will be for 5 years. So let's see what is now the cost of a new guitar today. So to do that, we'll take 1.1, because 10% is 0.1 plus 1 is 1.1. We'll raise it to the power of 5. Then we multiply this by 60,000. So if you multiply by 60,000, you will realize that the new guitar that Jacob wants to buy, which he bought for 60,000 5 years ago, now after 5 years that new guitar can no longer be 60,000. It's now 96,630 cents. But what is Jacob having? He's having 28,000 that he got from selling the old guitar, which he will now use as a deposit for the new guitar. So the amount to pay, at times they call it trade-in amount. If you've ever heard the word trade-in, it's for situations like this. So if I decide to say trade-in amount, then the trade-in amount here will mean that I will take now the cost of the guitar today, which is 96,630, minus the amount that Jacob is bringing from the old guitar of 28,225. 62 cents. So if I do this difference, I now see what is the cost, what is the amount Jacob will pay to acquire this new guitar after 5 years. So I'm subtracting 28,225.62. Sorry, 0.62. 28,225. There's a mistake there. 225.62. Yes, it's okay now. So the new guitar will be paid for 68,404.98 cents. So that is how we expect you to handle this kind of problems of the trade-off. They are very common with buying of cars. You can also buy a car, use it for 5 years, then you go and trade it in, and then you get a new car. So we'll do things like this to see what is left in the old car. Then once you get the new car, maybe it has appreciated after some time, then you get the value of the new car, then you subtract the value that comes from your old car. So those are the kind of things that we must expect in depreciation. So let's now look at the second problem there about Stella. It's more or less the same kind of reasoning. It says Stella invested 40,000 rands in shares. So that is the original amount. Each time I use the word invest, that is my original. Her investment depreciated on a reducing balance basis in the first 3 years at 6%. So the type of depreciation is reducing balance basis in the first 3 years at 6% per annum. So it means she invested 40,000 into shares. That's the original value of the shares, but unfortunately for her, it's like business didn't do well. Her shares depreciated at a reducing balance method for the first 3 years at 6% per annum. Then after that, her investment grew is now appreciating, grew at 11% compounded quarterly. Determine the value of the investment after 8 years. So with this kind of problem, we look at the first 3 years to see what was happening to Stella's investment. There was a depreciation at a reducing balance basis. So we know the formula for depreciation. The original cost of the shares was 40,000. The depreciation rate was 6% for 3 years. So we'll see what is the value of our investment after 3 years. So we'll get 60,000. No, it's 40,000, not 60, 40,000 into 1 minus 6%. That is 1 minus 0.06. Then we'll raise it to the power of 3 since it's for the first 3 years. So we'll raise it to the power of 3. So that gives us 33,223.36. So you can see that our shares have actually lost value in the first 3 years. They depreciated on the reducing balance method. They went from 40,000 to 33,000. So we now need to determine, then after that, our investment grew at 11% compounded quarterly. So now we are looking at the next 5 years because we are already started with the next 3 years. We are determining the value of our investment after 8 years. So it means you need to add 5 for it to get 8. So I was saying next 5 years, so that if I add 5 to that, I will get 8 years. What happened there was an appreciation. Appreciation now takes us to compound interest formula. So formula 24 on our formula sheet, I think that is what I'm targeting. So it is written like this, raise the power t times n. So that is the way it is, where a is the value of the investment at the end of 3 years, which is there. Our R represents our interest rate of 11%. Then N here is representing the part of compounded quarterly. So when it's quarterly, our N will be 4. If it is semi-annually, we use 2. Weekly, we use 52. Daily, 365. Monthly, our N will be 12. Then T represents the time, which in this case, it's a 5-year period. So our investment now is, Stella's investment is now continuing with this figure that it ended with after 3 years. So we have 3, 3, 2, 2, 3,36, bracket 1 plus 11% times 4, because we are told that it's quarterly, raised to the power 5 times 4. So that is what we'll do. So in some other questions, they will even give options for doing a withdrawal after 3 years. Let's say there was a withdrawal of 10,000, then we'll be subtracting 10 from here, so that we're left with 23,000. But here there was no such option. So that is what we get. So I have to capture this calculation into my calculator. I get 33,223,36 in bracket. I take 1 plus 11 on 400. That is it. 100 times that is 400. Then I will raise this to the power of 5 times 4 is 20. So that will take me to 57,000. So this takes us to 57,158,41. So that is now the value of Stella's investment at the end of 8 years. So guys, that is how simple it is. In some other problems, you might even go further to say, calculate how much Stella has gained in her investment from the first day she invested. She invested originally 40,000. So if I want to see her gain, I will take 57,000 minus 40,000. So that is just it, guys. So I believe we have managed to touch all the things that deal with depreciation and where they combine with appreciation. And I hope this helps you. Thank you very much.